In this section, we get to solve right triangles that are not set inside the unit circle. So we get to just expand out into the world and look at applications and triangles. All right, so let's go ahead and get started. We're used to the sine of some angle. All right, so let's get started. We're used to the sine of an angle. We've just been calling that y. Well, we've been able to do that because we're in the unit circle and the radius is 1. Technically, the sine is actually y over r. And so then cosine is x if you're in the unit circle, but if you're in a unit circle that has a different radius, it's x over r, and then tangent is y over x. And some of you might have learned this in high school geometry, where it's called SOHCAHTOA. The sine is the s as the opposite over hypotenuse. And then the ca is a reminder that cosine is adjacent over hypotenuse. And TOA is the tangent is opposite over adjacent. So, and then also we have our reciprocal functions as well here. All right, so the nice thing about orienting it this way instead of just calling it y and x is because now we can move our circles all over, or our triangles all over, and it doesn't have to be on an xy coordinate plane. All right, so let's go ahead and work on these. So let's see, from angle A, let's find the 6 trig ratios. Okay, so the sine of angle A, I want the cosine of angle A, and the tangent of A, and then also the reciprocal. So the cosecant of A, the secant of A, and the cotangent of A. All right, so sine is opposite over hypotenuse. Now hypotenuse, that's the word that we use for the radius of a circle, but it's also the diagonal hypotenuse. Okay, so it's the one that's always across from the 90-degree angle. That is the hypotenuse. And then who gets to be considered opposite or adjacent? It is all about what angle we're looking at. The opposite would be the one that you have to cross through the triangle to get to. All right, so we have opposite. That would be the one that you have to walk through the triangle to get to. So it would be 24, and then the hypotenuse, that's always the one across from the right angle. So hypotenuse is always across from that 90-degree angle. So that is going to be 25. Cosine, that is adjacent over hypotenuse. Okay, my hypotenuse didn't change. It's always the diagonal line, the one across from the 90-degree angle. But what's changed is that let's see who's considered adjacent. Well, from angle A, you see how there's 2 rays coming out to create that angle. The one that's touching my angle, well, there's 2 of them, right? One of them is the hypotenuse. The other one is considered the adjacent. Okay, so that is 7. Okay, so there's my fraction for cosine, and then tangent is opposite over adjacent. So it would be, let's see, opposite it's still 24, and adjacent is 7. Okay, good. And then once we've gotten that done, we just need to write the reciprocals. So 25 24ths. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So we would just flip that one over. And tangent and cotangent are reciprocal, so we just do the reciprocal of tangent to find cotangent. Okay, but just be careful, because if I had said find all the trig ratios of angle C, it would have been quite different. So from angle C, the thing that's, well, hypotenuse doesn't change, right? That's always the diagonal, so hypotenuse would have stayed the same. But now the thing touching, we've got two lines creating angle C. One of them's hypotenuse, the other one's adjacent. So here the 24 would have been considered adjacent. And then to get to opposite, you have to walk through the triangle to get over there. And then notice all of my ratios are different. Okay, so it really does depend a lot on what angle we're being asked to look at. All right, so moving on to example 2, I'm going to scoot this back over. Okay, so for example 2, we have cosine of some angle is 2 over 3. Okay, looking at the definition of cosine, cosine is adjacent over hypotenuse. Okay, so I can kind of figure those out. Let's see. I'm just going to label this as alpha. Adjacent, that's there's two things touching my angle, right, that create two lines creating that angle. One of them is the hypotenuse. That's the diagonal. Okay, so hypotenuse is 3, and then the other one touching my angle, that would be adjacent, and that is 2. Now to get to the other side, you have to walk along through your triangle, so the other side would be opposite. Okay, using Pythagorean theorem, we can say 2 squared plus whatever that opposite is. I'll just call it x squared is equal to 3 squared. So x squared would equal 9, and then we can just subtract 4 from both sides. So x is equal to the square root of 5. So that is square root of 5. All right, now we can do all of our trig ratios. And sine is the opposite over hypotenuse. So that would be square root of 5 over 3. Cosine we already knew, that was given, 2 over 3. And tangent is opposite over adjacent. So that is square root of 5 over 2. Good, and now we just need to do our reciprocals. So I'm going to give myself a little bit of room. Okay, I have cosecant. That's the reciprocal of sine, so it would be 3 over square root of 5. And then we do just need to rationalize that denominator, so that would be 3 root 5 over 5. And then the secant, that's the reciprocal of cosine, so it would be 3 over 2. And then cotangent, that is the reciprocal of tangent. And just rationalizing that denominator, we would get 2 square root of 5 all over 5. Done. Okay, so let's solve for x in this next one. So we are trying to find, let's see, I have an angle across from my angle, that would be the opposite side, and then I have this, what I want to know is the side that's touching my angle, which it would be the adjacent. Okay, so then we just go in and decide which one do we want to use. And since I have an opposite and an adjacent, that means I should use tangent. Okay, so we're going to use tangent. Tangent of 33 degrees is equal to the opposite, so 15 over adjacent, which is x. And then we'll just solve for x here. If I multiplied both sides by x, then I would get x times tangent of 33 is equal to 15, and then dividing through by tangent of 33. So it would cancel, so x is equal to 15 divided by tangent of 33, and pull out your calculator and you'll get that that is approximately 23.097. And just make sure you're in degree mode. Usually I only round to 2 decimal places, but this example in homework asked us to round to 5. Okay, in this one we need to express x and y in terms of theta. So let's start with x. So I have this theta, I have 2 angles, or two lines that create my angle. Okay, one of them is the hypotenuse, and then the other one is the adjacent. Okay, so then I think about SOHCAHTOA. Okay, I have adjacent and a hypotenuse, so that is telling me adjacent hypotenuse. I should use cosine. So I have cosine of theta would be adjacent, which is x, over hypotenuse, which is 24. And I'm supposed to write x in terms of theta. So that just means solving for x. Divide both sides, or multiply both sides by 24 there. So I have x is equal to 24 times cosine of theta. Okay, let's try this with y. Y, I have to walk across the triangle to get over there, so that is my opposite. Okay, and opposite over hypotenuse, that is sine. So then I would have sine of theta is the opposite, which is y over hypotenuse. And same strategy here, clear fractions, and we get that y is equal to 24 times sine of theta. Nice. Okay, next one. Without a calculator, we can evaluate these. Well, this just goes back to our unit circle. So cosine of pi over 6. Okay, that is square root of 3 over 2 plus sine of 30, and that would be 1/2, same angle, minus cosine of 60, and that is 1/2. And then tangent of pi over 4 is 1. Okay, and so let's see, our halves, that just adds up to 0. So we have square root of 3 over 2 plus 1. Quantity squared, so that's going to be multiplied times itself. And so this would be square root of 3 times square root of 3 is square root of 9 over 4. And then plus square root of 3 over 2 plus another square root of 3 over 2 plus 1. So then that would simplify to 3/4 plus 2 root 3 over 2. There's 2 of those, so I'm just adding that one and that one up to get 2 of them. And then plus 1. So let's see, I'm going to just, since I'm going to add my 3/4 and my 1, I can just think of this as 4/4. So final answer there would be 7/4 plus root 3. Right, because these 2's canceled. All right, let's do another. That's kind of a strange thing that is just thrown into this homework, but there it is. Okay, so, we're going to solve this triangle. So, I'd like to just start labeling things. Let's see, it doesn't really matter what you call them. This is my 90 degree, so this is angle C. It just kind of helps me personally stay organized. So if I have angle A, B, and C, and then I'm going to have my side length A, B, and C. Okay, so angle A, that was given 38 degrees, and side C is given as 7.8. Angle C is 90 degrees. So one of the things that you learn in geometry is that the sum of all the angles in a triangle add up to 180. So that's useful. So we've got 180 would be the same thing as angle B plus C, which is 90, plus A, which is 38. So then you can solve for B there, angle B. That ends up being 52 degrees. Okay, and then let's see, C we knew, and we are going to need a trig ratio here. So from the angle that was given, I'm going to use the opposite. And then we are given the diagonal, that's our hypotenuse. Okay, so who are we going to use? Right, we have a opposite. And we have a hypotenuse, so that means we need to use our sine. Okay, so the sine of our angle, which is 38, and I'm using that 38 instead of 52 just in case maybe I made a mistake with my subtraction there or something. Okay, so sine of 38, that's the opposite, which is A over the hypotenuse, which is 7.8, and then just multiply both sides by 7.8 here. plug that into your calculator. Okay, and we get A is approximately 4.8. Okay, and then we can use the either trig or we can use Pythagorean theorem to get that last side. I'm going to just use, let's see, just to show you, from angle A, let's see, I have this would be adjacent. And I have hypotenuse, so I could also use cosine of my angle is adjacent, which would be B over hypotenuse, which is 7.8. And again, just solving here, multiplying both sides by 7.8, we get B is equal to, or approximately, 7.8 times cosine of 38, which is 6.1. And I'm done. Okay, let's try this next one. So these both share a side. So I think if I could find this side, I'm going to call that Y. So here you need an angle and a side. And here we actually have two angles. You always need 3 parts of a triangle, and we have that 90 degree. Okay, so from my angle, I have an adjacent, and I want the one that's across from the 90, that would be the hypotenuse. Okay, adjacent hypotenuse. Okay, we have adjacent, we want hypotenuse, that means we should use cosine. Okay, so cosine of 39, that would be equal to the adjacent, which is 4.5, over the hypotenuse, which is what we want. And then you can either cross multiply or just multiply both sides by y and then divide through by cosine. So we'd have 4.5 divided by cosine of 39 degrees. And that gives us that y is approximately, let's see, 5.7904. It's nice to round out to about 4 decimal places when we have to do multi-step problems, just to reduce our error. Okay, let's keep in mind what we wanted. We wanted to find x. Okay, so now I'm going to